All right, so this is the video for Unit 7, Assignment number 7. We're going to be solving polynomials by factoring. Let's go ahead and get started. So here we have number 1. We're going to solve this polynomial given that negative 3 is one solution. So if negative 3 is one solution, we know that one of the factors has got to be x plus 3. So we're going to find the other factor. And we're going to do that by using, let's say, synthetic division. So I'm going to have a negative 3 in the little box here. That's a negative 3. And I'm going to have 1x to the third minus 3x squared minus 10x plus 24. And so when I synthetically divide, I'm going to bring down the 1 times negative 3, which is negative 3. Then negative 3 plus negative 3 is negative 6. Negative 6 times negative 3 is positive 18. Positive 18 plus negative 10 is positive 8. 8 times negative 3 is negative 24. And I do get a remainder of 0, which means x plus 3 is a factor and negative 3 is a solution. And my other factor is x squared minus 6x plus 8. And then hopefully I can factor this factor again. So I'll have x times x, that gives me x squared. And then I need something that multiplies together to give me 8, but adds up to a negative 6, like a negative 4 and a negative 2. And so that's how I would factor this factor. Those three factors equal 0, which means one of these three has to be equal to 0. If it's x plus 3, then x is negative 3. That's one solution. If it's x minus 4, then it's x is 4. That's a second solution. And if x minus 2 is equal to 0, I would add 2 and get 2, and that's my third solution. Let's take a look at a similar question. Let's take a look at number 2 here. Again, we are given that x minus 3 is a factor. And so that means one factor here is x minus 3, and we have to find the other factor. So again, I am going to use synthetic division. I'm going to put a positive 3 in the little box. I'll have negative 2x to the third, a positive 15x squared, a negative 22x, and then a negative 15. And if I synthetically divide here, this is negative 2 times 3, which is negative 6. I add and I get 9 times 3 is 27. I add and get 5, and 5 times 3 is 15. And when I add negative 15 plus 15, I get a remainder of 0, which means my other solution, or my other factor, is negative 2x squared plus 9x, and then plus 5. And I don't believe I can factor this, so I'm going to use another method. I'm going to use the quadratic formula, which is negative b. So I'll have negative 9 plus or minus the square root of b squared, which is 81, minus 4 times a, which is negative 2, times c, which is 5, all over 2a, which is 2 times negative 2, which is negative 4. So inside the square root sign, we're going to have 81, but I have two negatives there, a negative 4 and a negative 2, which means it's going to be 81 plus 4 times 2 times 5 is 40. And that's the square root of 121, and the square root of 121 is 11. So if I move down here, I have negative 9 plus or minus 11 all over negative 4. Negative 9 plus 11, well, that's 2. 2 divided by 4, negative 4 is negative 1/2. That's one of my solutions. And then negative 9 minus 11 is negative 20, and negative 20 divided by negative 4 is positive 5. And so my three solutions are 3, which is from this 0 up here, negative 1/2, and 5. Let's move on here. So we have that 2 is a solution to this particular problem, and so again, I'm going to go through that step again. I'm going to use synthetic division. I'm going to have 1, negative 2, 1, negative 2, and one of my solutions is 2. And so I'm going to use synthetic division here. We have 1 times 2 is 2. That's 0 times 2 is still 0. 1 plus 0 is 1 times 2 is still 2. And so I have a remainder of 0. So my two factors are x minus 2, because I know that 2 is a solution, My other factor is x squared plus 1 equals 0. So one solution is when x minus 2 is equal to 0, and that's 2. Of course, we knew that already. The other solutions come from this equation, x squared plus 1 equals 0. And we can use square roots to do this problem. I could subtract 1 from both sides, so x squared equals negative 1. And when I take the square root of negative 1, I'm going to get that x is plus or minus I. And so here I have three solutions. One of them is a real solution, and the other two are imaginary solutions. Let's try a little bit different type of a problem. This is called the sum of two cubes. I'm going to do this two different ways. The first way is the same way that we've been doing the other problems. I'm going to use synthetic division and try to solve this first. I can start solving it by subtracting 8. So I would get x to the third equals negative 8. Then I could take the cube root of both sides. If I take the cube root of x to the third, that's just x. And the cube root of negative 8 is negative 2. Because negative 2 times negative 2 times negative 2 is negative 8. Which means one solution is negative 2. Well, then I can use that one solution and synthetic division to find my other solution. So for example, synthetic division, I'll have 1x to the third plus 0x squared plus 0x plus 8. My solution is negative 2, so that goes in the little box here. So I'm going to have 1 times negative 2 is negative 2. 0 plus negative 2 is negative 2 times negative 2 is 4. Plus 0 is 4 times negative 2 is negative 8. And so I do get a remainder of 0. And so I know one factor is x plus 2. And I know my other factor is x squared minus 2x plus 4. And so then I could solve both of these. If this one's equal to 0, I know that negative 2 is my solution. And then if x squared minus 2x plus 4 is equal to 0, I could solve that by using the quadratic formula. Negative b is 2, plus or minus the square root of b squared, that's 4, minus 4 times a, which is 1, times c, which is 4, and that's all over 2a, which is just 2. So in my square root, I will have 4 minus 16. 4 times 1 times 4 is 16. Well, that's the square root of negative 12. And I could simplify that. The square root of negative 12 is the same thing as 4 times 3, so it's 2i radical 3. Because it's 4 times 3 times negative 1. And the square root of 4 is 2. The square root of negative 1 is I. And the square root of 3 is still the square root of 3. So I could then write this as 2 plus or minus 2i radical 3 all over 2, which then would simplify to just be 1 plus 1i radical 3, plus or minus. And so those are my two solutions. There's an easier way to do this, and there's an easier way to get to this point right here. There's a formula for the sum of two cubes, and it looks something like this. If I have a cubed plus b cubed, that is the same thing as when I factor it, I'm going to get a small factor, which is this one, and a big factor, which is this one. So I would take a plus b to get my small factor. To get my big factor, it's always going to be a squared. So that's this number squared. The last term is going to be b squared. And then my middle term is simply going to be a times b, and it's going to be a negative of that. This formula right here will help you get to this point much faster. For example, if I have x cubed plus 8, I know that the a is just x and the b is 2. So the small factor is going to be x plus 2. Then I'm going to get the big factor. The big factor is going to be x squared because it's this number squared. The last term is going to be 2 squared, which is 4. And the middle term is going to be negative x times 2, which is 2x. And you can see this right here is the same thing as this right here. I was just able to get to that point much quicker by using this formula than using synthetic division. Let's apply that to a different situation. Let's say that we have something like this where we have the difference of two cubes. What we just did is we wrote down the equation for the sum of two cubes, which is a, which is a cubed plus b cubed, and that formula is this. Two factors, one small factor is going to be a plus b. The big factor is going to be a squared minus ab plus b squared. Well, if I have the difference of two cubes, that's a cubed minus b cubed. Again, I'm going to get a small factor and a big factor, and everything's the same. A and b and a squared. This is b squared. This is a times b. The only thing that's different is if this is a minus sign here, so is this. And then these would both be plus signs. And so this is the formula that I'm going to use for this problem. My a value, the cube root of 27 is 3, and the cube root of x cubed is just x. The cube root of 1 is 1. So I'm going to have a small factor, which is 3x minus 1. And then I'm going to have a big factor, which means I'm going to take 3x and square it, which is 9x squared. 9x squared. My last term is going to be negative 1 squared, which is 1. And then my middle term here is going to be 3x times 1, which is 3x. And these are both going to be plus signs. So when I solve this, these are equal to 0. If this one's equal to 0, I would add 1, divide by 3. And that's one solution, 1/3. And then to find this one, I would use my quadratic formula again. Negative 3, negative b is negative 3, plus or minus the square root of b squared, which is 9, minus 4 times a, which is 9, times c, which is 1. And so this is going to be 9 minus 36, which is negative 27. Okay, and so the square root of negative 27 is like 1 times 9, negative 1 times 9 times 3. So I can rewrite it as negative 3 plus or minus, the square root of 9 is 3i, radical 3 over 2 times a, that's 2 times 9, which is 18. And then this whole thing can simplify to negative 1 plus or minus I radical 3 over 6. And that's if I divide out all of these real numbers here by 3. And so those are my 3 solutions. Let's take a look at a different type of question. Let's move on to looking at special cube roots, or special 4th degree equations. And for the sake of time, I'm going to go on to the second video here. So we have just 3 more problems. They're not going to take too long, but I'm not going to be able to finish it in the time that we have. So let's go on to the next video.